Okay, I'm back. It's been too many days. Sorry, me. Okay, and I'm back. Friday we had some physical shit at work. It was all day outside, running and exercise and shit. So I passed out from like 4 or 8, and then instantly fell asleep again and woke up. Got out of bed the next day at like noon. I had, who knows, 16 plus hours. It was fucking crazy of being in bed slash sleeping. Then I watched all of Solo Leveling season 1 and season 2. 16 hours because I like rewatching pieces. So it was like 3 extra hours, but it took basically all day Saturday. Plus I had D&D 5 or so hours, so I stayed up an extra like 5 or 6 hours past my standard 16-hour awakeness. And it fucked up my sleep on Sunday. So excuse Friday, exercise stuff, work stuff. Excuse Saturday, needed to watch the new season, so I had to watch the old season of Solo Leveling. And that fucked up my second day, my Sunday. I couldn't even really read well. Laying down reading my novel, but excuse me, couldn't make much progress, so I had to start watching Severance. I'm caught up on season 1. 2 episodes in season 3, going on to episode 3 season. But wanted to ease into it today. Get in it. Meant to do 4 hours, and that turned into 2. Needed to do some Severance. Takes. I'm gonna get an clean hour and 20 real quick, and then tomorrow we'll be back to the 4-hour a day, same shit. I have to watch dogs again later on this week. Some bonus cash. $50 a day to force myself to program anyway. So, or rather, a physical location where all I can do is program on my laptop. So this is good. That fucking said. All right. Continuing inline variable. It's been since fucking Thursday. Since Friday, Saturday, Sunday. 3 entire days. Program. Terrible. Terrible. So, inline expansion. We do this to take a to reduce the overhead to eliminate the overhead cost of a function. Do it when the overhead cost of a function is somewhere on the same level of magnitude or whatever. We'll say it's approximately similar it's in cost. The actual functions, logic, functions, statements, the functions, function itself, function's purpose. The purpose of the function costs 1, and the overhead costs 2. Copy variables from arguments. So copy them and store them in temporary memory somewhere. Instantiate and assign memory locations, spaces to the arguments. Pass the copied values into those arguments via copy assignment. To then run the logic in the code or in the function, and then to return that value back non-void function, or if it's a value returning function. Well, besides running the code, so that's the temporarily copying the value of the arguments, instantiating parameters, copying the values into the parameters, so initializing the parameter, and returning the value. 4 separate pieces there: copying, instantiating, passing, returning. Those 4 pieces together are anywhere similar in terms of cost of the function's code itself. And if we do that function a lot, let's say it's adding, the statement that adds and returns numbers small. Complexity of, or the cost, copying the arguments, passing them to instantiated parameters, it's probably about similar. we run that a whole bunch, the overhead of the function is going to probably double-ish or more cost of the function. So there's the cost of the overhead, and then there's the actual cost of the function. We do inline expansion. We use the keyword inline to allow us to do multiple. Oh, I think my volume's fucked. Yep. Yes, it is. We use the inline keyword to tell the compiler, well, to tell the linker, yo, buddy, it's okay. We can multiply define, we can redefine this function. We can do it multiple times. We can have a definition here in our header file, and we can include that into one file. And yes, there's now technically a definition in the header file and in the file within which the header file has been included. If the compiler doesn't check header files, I think it does, but if it doesn't, well, if we include the header file into another file, then we will then have two CPP files that both have the same function declaration, or same function definition inside them, because it's not a for declaration, it's a definition. The thing here is inline functions. The files where inline expansion is going to happen, it needs to have the function defined, not declared. It needs to see the entire definition, the compiler does, so that the compiler can do the inline expansion. So the inline keyword allows us to bypass the one definition rule by saying, hey, there's a definition here, there's a definition there, combine them, and then just something like that. It combines them somehow into one definition still. It goes, I think it's the linker. The linker is going across and eliminating redundancies and replacing things so that there's technically only one definition somewhere. I guess that's it. The linker needs to see the one definition. So the linker sees, oh, okay, inline, these two are the same definition, therefore it is one definition. Therefore it doesn't violate the one definition rule anymore. The rewards, those files that have the inline redefinition of a function the compiler can now do inline expansion, which takes the logic of the function and replaces the function call with that logic in that line of the function that called the function, likely main. Now, we don't take any arguments and copy their values temporarily and pass those to, and then instantiate some arguments and then pass the temp values into the arguments and then return. All we do is run the logic, and the result is returned right there. So if anything, we just have the result, which is just the evaluation. And that's it. Boom. We've taken out the arguments being copied. We've taken out parameters being instantiated and initialized. And we're just running the code, and it has a result. That's it. We don't have to pass it to something. It's just there. Boom. So why they are allowed, let's see. Oh, my glasses came back. Apparently my prescription was reduced. So allegedly these should be good for computer stuff now. I still felt them being shitty earlier. Oh, they're so big. Yeah, I still definitely lose depth perception. That's annoying. Well, it still sharpens things up though. I'm still just gonna have to take them off after using the computer. But okay. Guess it's for eye health, so it's okay. I don't know why I have this. I'm not sure. I don't need this ruler. I have rulers. Cool. Okay. Well, eye health will be better. Why is this harder? This cloth doesn't smell good. Okay. Had a phone call scheduled for tomorrow morning, but turns out the people are kind of creepy, so I'm not going to answer it. Okay. Yep. As soon as we copy the definition into each, we violate ODR. Yep. So we make inline functions exempt. Yes, because it's the compiler that's doing the inline expansion. But it's the linker that would compare with other files to check. Because compiler works sequentially. So it can't check the other files. Yep. Mm-hmm. Yep. Makes sense. If it's not in line, the linker should be catching it. But if it's in line, yep. When we use inline, we're basically certifying, hey, this definition is the same as the other. It's the same one. We want inline expansion, so it's okay, linker. It's okay, buddy. Hmm. So the compiler sees inline and goes ahead and does inline expansion. And the linker says okay and doesn't give an error because if it's marked as inline, any call to the function to that identifier, add, and then passing it two parameters, that has to be the same function as any other add with two parameters that's inline. So if we put inline, the linker's happy. If the compiler decides that expanding inline, because again it's on the compiler, even though we put inline, the compiler doesn't have to do it. It checks to see if inline expansion makes sense. If it's not, and then it sees, oh, now it sees add instead of just replacing it to be the logic of adding the, like if we do add 2 and 4, inline expansion would remove add and just say 2 plus 4. Just swap the logic. Well, let's say maybe the overhead for add isn't high enough and inline expansion is not going to happen. So the compiler leaves it as add. Well, you'd think there's a definition in this file, there's a definition in that file. If we're calling a function here, but it's defined somewhere else, there might be a conflict there. Something's going to give an error. But no, we've put inline. We have certified that no, there are no conflicts. So we can still use add, and it will still return 6, 2 plus 4, and call the function as it should. Doesn't matter technically where, but I mean, if it's in this file, it's probably going to call the function that's in that file. So, cool. Yep, we're defining them in header files, as I guessed before. The reason I guessed that was because if we can define these guys multiple times, then it makes sense that instead of hard coding them into multiple files, like there was an example before where we hard coded it into 2 separate ones. Now we just put them in the header file and we include them and we're good to go. So if I do an example, I'm probably going to go to bed shortly. I meant to do 2 hours, but I need to do this early enough. I'm too tired. I have to just get home and then just eat and then boom. It was a mistake watching show first. Show should come right before bed. Because I need more of my intelligence remaining and my brain stamina remaining for this compared to consuming media. Let's do we'll do an inline function. We'll just do we can do string after alphabetically because they're both from the same library, the standard library. Excuse me. Cool. Oops. Just wanted to test some knowledge. Even though I haven't done massive projects, because the amount of time I spend with each of these topics pretty strongly ingrains it into my mind, which is nice. Okay. So, I want to have a skeleton. He has a certain health, and we're going to name him the target. Target is the skeleton. The skeleton has a certain health, and we're going to have a function. We pass the target and the health, and it just outputs it. Easy enough. IOStream will be included transitively, so within the header file that we're already going to be including. So here we're simply going to say there's a string, and it is called player target, and it is called skeleton. And then there is an integer here. Sure, we'll just value initialize, it's fine. And it has 100 health. It's at max health right now. That's fine. Oh, hold on. What is happening? Oh, why did I... Tired, I accidentally put in the ASCII. Or not even the ASCII, but the C-style string literal. Now we're not using that yet, but that's fine. Okay, we'll have a header file. It'll simply be called inline target function. We need a header guard so that when we include this in the multiple files, there aren't issues. And well, really the main thing is we don't want to be able, we do not want to include this if it's already been included in one file. We don't care if it's included in different files. So we'll make sure that this is not defined. Inline target function h. This is a what is this? An object-like conditional preprocessor directive macro, something like that. Basically, this executes for anything. I think before it's like at an early part of compilation, or maybe even before compilation, this happens. What we're going to be doing is we're going to include input and output, and we're also going to make an inline function. The inline function is void, so we don't have to worry about the return part of the overhead, but we do have parameters and arguments, so this is okay. We'll just call this print target stuff, and we'll say we'll leave the standard string that way inline expansion actually happens. So we're just moving. What we want is to directly use this standard string instead of having to copy it, which is expensive, and then pass it here, which is expensive. So instead of doing a string view, that might lead the compiler to not do inline expansion, but here still won't know if it's doing inline expansion. But I think it would be more likely here by making the function more inefficient or less efficient. That should increase the chance that, or by increasing the cost of overhead, it should increase the chance that the compiler will decide to perform inline expansion, which the inline keyword is not required for. Standard string, and we'll just call it target, and an integer. Doesn't matter if it's const or not, but it's okay. We'll say a const int. Oh, well, yes, that means that we can't change it within this function. Constant target health. Target health. And we'll just say target name. Cool. Target name and target health. This is going to output and say target name health is, or target is named skeletons remaining health is, or has target health remaining health. This is okay. Still haven't used this just yet. Now we need to call it. And suppose we could do a namespace here. Namespace target stuff. Same thing. And now we can simply include our user-defined header file, inline target function, or I could just do inline target function. Cool. Yeah. Let's see. Player has target. Want to print target's info. So we do targets. Oops, this is supposed to be capitalized for best namespace practices. Target stuff. Print target stuff. And we will pass it player target and player target health. Oops, should have just done delete. Cool. It has 100 remaining health. So what should be happening here is we are including string. So we're including our user-defined function, and we're doing that before string because we want the standard library stuff to happen after. We want to have compilation errors happen as soon as possible. So if there's something missing, and if we're using something in the inline target function and it hasn't been included yet, we want that to pop up first instead of including all these other things that are not user-defined. And then if we actually have issues in our user-defined header file, then those won't pop up because we've already manually included the stuff that it might be missing, the dependencies. So we have a header guarded inline target function header file. What it does is it allows us to use input and output streams. So input streams and output streams, which are types. It has a namespace in it called target stuff, within which we have a function that allows us to print our target and its health. It has two arguments, a standard string and a const int. Thus, when we call it, we have two arguments. The overhead cost is the cost of copying the argument values and storing them somewhere temporarily in memory. Instantiating target name and target health. These are two parameters. We have to give them some space somewhere. That has a cost associated with it. And then we have to copy these temporary values that we've already copied. We have to take those temporary values and now we have to pass them here. So we have to copy, instantiate, and then initialize by passing those values here from wherever we had them. There's no return, so there is one less thing. There's normally a fourth piece of overhead. Only 3 here, but this copying will be pretty expensive. Initial instantiation, maybe not. We're just giving it pieces of memory. But I think standard strings can be large, but they're dynamically allocated, I think, too. So right now they might be pretty small. Because they're probably value initialized first. Maybe they're not, though. Maybe they're just default initialized. I'm not sure. And then the copying. So we have copied and then we have passed, which is copy assignment. So it looks like we've done 2 forms of copy assignment here. Plus, given these guys memory, it's probably more efficient to just run this logic straight away and then replace target name with player target, target health with player target health, and then run it here instead of actually having to copy, instantiate, pass, run. It's probably better to just run logic on these 2. Done. Cool. Okay. I have an inline function here. What happens if I say const void? Oh, you can have a const void. Noted. If I did inline static, oh, it's okay. Because I'm accessing it via namespace, perhaps? So if we took out the namespace, and we just used it via local scope. Took out the namespace. Oh. It actually still works. Oh. Well, that's why. This is not in a CPP file. This is in a header file. And it's being included here, so the definition is actually here. So if I had a CPP file, we'll just call him test. We will define this guy here. And then we'll just say for declare here. Oh, true. This isn't needed here. We'll include him. Yeah, we'll do them all. We're not actually doing anything here, so we don't need input output here, but we do need this here. If I removed static. Oh, still having issues. Oh, I think you need to know what that means. Because it's actually being run. Oh, wait, hold on. You at least need to know string. Maybe the issue is because we've included it before we included the definition here. Let's see. Getting a linking issue here. Oh, same for you. Everybody has string. We don't actually need string here then. Oh, the inline was the issue here? This is fine. All we're doing is for declaring him here and including him. He needs strings so that he knows what the hell's happening. Same with you. I'm not used to that because usually it's because I've never had to include a library for parameters before, really. So even my for declaration needs this, but so does the definition in order to even exist without a compilation error. Oh, that's the issue. When we make this guy inline, the compiler will flag, or rather the linker will have an issue because it's going to see oh. It doesn't see what the logic is. So it's defined here, but I see. The link issue means that we've compiled, we're cool. This is cool. We got a for declaration to the guy. He's defined here. Okay. It's at least usable in here. So this guy has been included and he's in here. We're then calling and we have here. The problem is we're not talking to this guy. The reason why, because of inline. What is inline doing? Well, wherever inline is, we need, in order for us to actually perform inline expansion, we need the definition to be in the function, in the file that we're using. And the problem is we are using an inline function in here without this file having the definition. So if I instead take this, remove that, then give this input and output so that it knows what the hell the logic is, now we're okay. The reason is because now this file is using an inline function and it actually has the definition. Cool. So when I open that up, what's gonna happen? So these sometimes don't like deleting. Yes. Who gives a fuck? Cool. Okay, I will continue tomorrow. That wasn't much time. Oh, somehow 40 minutes, but probably 7 minutes of yapping. I'll continue tomorrow. I need to go to bed. Tomorrow I need to lock this habit in for good. Come home, eat, boom, go. And then watch a show after. Maybe one episode, but just started too late. I can't even start at 8 because in 4 hours I get 3 in, it's 11. I get 2 in, starting to get tired. I just need to start earlier. So start at like 6 and then I can get a nice 4 hours in and then I'll be energized. That's the difference between the days where 4 hours goes by quick and 4 hours takes a while. So it's just how awake I am. Need to be more awake. Noted. Okay.